The engine is made out of aluminum based on their long experience of making turbocharged engines and our experience of producing engines in China. This engine comes in both hybrid and plug-in hybrid powertrains on other markets.
For decades, the car industry believed gasoline engines had already reached their limits. Major automakers spent billions trying to improve fuel efficiency, yet real breakthroughs became rare. But now, China may have completely changed the game.
China has become the world's largest auto exporter, and it is just starting to ship electric vehicles.
A new engine, claiming an incredible 48.41% thermal efficiency, is sending shockwaves through the global auto industry.
China would be destroying it. China is in the process of dominating the global motor industry and to any country's car manufacturing industry that's still standing.
And forcing competitors to pay attention. Some experts believe this technology could reshape the future of cars, while others are questioning how China achieved something companies have chased for years. So what exactly makes this engine so special? And why is the entire world suddenly talking about it? Join us in this video as we reveal the details. The engine that rewrites the rules. The secret behind Geely reaching an unbelievable 48.41% thermal efficiency starts with something most drivers have never even heard of: an extreme Miller cycle combined with what engineers call a fire tornado combustion system. And honestly, this is where the entire industry starts to panic. In a normal petrol engine, the air and fuel mixture enters the cylinder unevenly, almost like water being dumped into a glass. Some areas are rich with fuel, others are lean, and the mixture becomes chaotic. When the spark plug fires, the flame has to chase its way through all those uneven pockets. That process only takes milliseconds, but even those tiny moments matter. Because while the flame spreads, heat is already escaping into the metal walls of the engine, wasting energy before it can move the piston. Geely decided to attack that exact problem. Using advanced fluid dynamics simulations, their engineers completely redesigned the intake ports. So now, when air enters the cylinder, it does not simply flow inward. It gets slammed into a violent vertical vortex, spinning at extremely high speed. A literal tornado forms inside the combustion chamber, and that changes everything. The moment the high-energy spark plug ignites, the turbulence spreads the flame across the chamber almost instantly. Instead of a slow, uneven burn, the combustion happens with near-perfect precision. The fuel burns faster, cleaner, and far more completely before heat can escape into the engine block. That ultra-lean combustion dramatically reduces wasted fuel and unburned hydrocarbons while maximizing the force pushing the piston downward. Every explosion becomes more controlled, more efficient, and more powerful. But Geely did not stop there. To squeeze every possible drop of energy out of the fuel, they pushed the Miller cycle to extreme levels and raised the compression ratio far beyond what most traditional engines can safely handle. That allowed the engine to extract more expansion energy as the piston traveled downward, turning more heat into usable motion instead of waste. Normally, this is where engines begin destroying themselves. Extreme compression creates extreme temperatures, and high temperatures create engine knock. That premature detonation can crack pistons, damage cylinder walls, and destroy an engine in seconds. Most automakers avoid pushing compression too far because the risks become enormous. Geely solved it with an entirely different thermal architecture. Instead of using a traditional cooling system where coolant flows through the engine at roughly the same temperature, Geely split the engine into two separate thermal zones. The cylinder head, where those violent fire tornado combustions happen, is aggressively cooled to keep temperatures as low as possible. That prevents pre-ignition and allows the engine to survive those massive compression levels safely. But the lower engine block is intentionally kept hotter. That sounds backwards, but there is a reason. A warmer engine block keeps the oil thinner, and thinner oil creates less friction against the piston rings as they move up and down. Less friction means less wasted energy. So Geely essentially built an engine that operates cold at the top and hot at the bottom at the exact same time. It completely breaks traditional engine design logic. The entire system is controlled by an intelligent electronic water pump that constantly adjusts coolant flow depending on load, speed, and temperature conditions in real time. It is not just cooling the engine, it is actively balancing thermodynamics every second the vehicle is moving. But even a 48.41% efficient engine would still be pointless if the drivetrain wasted all that energy afterward. And this is where Geely made another move that shocked the industry. Most legacy automakers still rely on large, heavy transmissions filled with gears, clutches, hydraulic systems, torque converters, and synchronizers. Companies like Ford, Mercedes, Stellantis, and even Toyota continue adding increasingly complicated 8-speed and 9-speed gearboxes to their hybrid systems. Toyota's eCVT system was revolutionary decades ago, but today it still carries mechanical complexity and unavoidable parasitic losses. Geely looked at the entire idea of a traditional transmission and simply threw it away. To match the new engine, they created the 11-in-1 eDHT intelligent drive system. This is not a normal gearbox. It is more like a compact electromechanical power router. Inside one tightly integrated housing, Geely combined the P1 generator, the P3 drive motor, dual silicon carbide inverters, and thermal management systems together into one unified unit. By eliminating unnecessary mechanical complexity, they reduced the total powertrain weight by 13.5%. There are no bulky shift systems constantly changing gears, no hydraulic torque converters draining energy, no complicated synchronizers waiting to fail. And here is the truly shocking part. For most daily driving, the wheels are not even physically connected to the petrol engine. The system mainly works as a series hybrid. The engine locks itself into its absolute most efficient RPM range, exactly where it achieves that massive 48.41% efficiency figure and stays there. Instead of directly powering the wheels, it spins the P1 generator to create electricity. That electricity is then sent either to the Aegis short-blade battery or directly to the P3 electric motor powering the wheels. The petrol engine only physically connects to the wheels during high-speed highway driving. At around 80 miles per hour, electric motors become less efficient, so the system bypasses the electrical conversion process completely and mechanically locks the engine directly to the axle like a high gear in a manual transmission. It is a system designed to waste almost nothing, and that is exactly why the rest of the car industry is suddenly paying attention. Then Geely tested everything publicly. But what shocked automakers worldwide? Let's find out. The test that made automakers nervous. Then came the test drive that really got people's attention. While testing Geely's newest hybrid system around China's Hainan Island, the company claims an M-Grand prototype achieved an astonishing average fuel consumption of just 2.22 liters per 100 kilometers. That translates to roughly 105 miles per gallon. For a normal-sized sedan, those numbers sound almost unreal. And this was not some tiny experimental city car stripped down for a laboratory test. The hybrid system was also paired with a powerful 308 horsepower electric motor producing 230 kilowatts of output. So Geely was not sacrificing performance just to chase efficiency headlines. The car was still designed to feel fast, modern, and usable in real-world driving. That combination is exactly why the industry started paying closer attention. Because traditionally, automakers had to choose between power and efficiency. You could build a car that was economical, or you could build one that felt powerful. But doing both at the same time was extremely difficult. Geely suddenly appeared to be closing that gap, and the company was not shy about its ambitions either. Victor Yang, a spokesman for Geely, openly stated that the system would comprehensively surpass Japanese hybrid technology. That is a bold statement considering Japan has dominated the hybrid market for decades. Of course, real-world customer driving will ultimately determine whether the numbers fully hold up outside controlled testing conditions. Automakers have always been able to produce impressive efficiency figures under ideal circumstances. Even Toyota recently demonstrated just how far hybrid systems can go when it drove a Toyota Prius across the United States, from Los Angeles to New York. During that more than 4,500-kilometer journey, the Prius reportedly averaged around 2.53 liters per 100 kilometers, an incredibly impressive result on its own. But Geely's claimed numbers still pushed even beyond that, and the company says the secret is not just the engine itself. A major part of the system revolves around software and artificial intelligence. According to Geely, the entire hybrid platform uses a centralized electronic brain capable of controlling both the cockpit systems and the vehicle chassis at the same time. Artificial intelligence constantly monitors driving conditions, battery usage, power demands, terrain, and traffic patterns to optimize energy management in real time. In other words, the car is continuously making small adjustments behind the scenes to squeeze out every possible bit of efficiency. That is a very different philosophy from traditional hybrid systems, which relied much more heavily on fixed mechanical programming. Geely plans to expand this technology far beyond a single vehicle as well. The company says the new hybrid platform will also appear in models like the Geely Boyu L and the Geely Xingyue L, showing that this is not just a concept project or limited production experiment, it is becoming part of Geely's long-term strategy. And interestingly, the company does not appear ready to abandon combustion technology anytime soon. During a special event focused on the new hybrid system, Geely chairman Li Shufu revealed that the company is also exploring the future use of methanol fuel. According to Li, methanol may offer major advantages because its energy density is far higher than current lithium-ion battery technology. That comment reveals something important about Geely's overall mindset. While much of the auto industry is rushing toward one single future built entirely around batteries, Geely seems to be betting on multiple technologies evolving together at the same time. And if this hybrid breakthrough is any indication, that strategy may be starting to pay off. But efficiency was only beginning. So what powered this intelligent hybrid system? Keep watching to find out. The AI hybrid system built to replace old thinking. What makes Geely's new IHEV system so different is that the company did not just focus on building a more efficient engine. It tried to solve nearly every major weakness that has frustrated hybrid drivers for years. For decades, hybrid vehicles have always come with compromises. Some delivered great fuel economy, but felt slow and lifeless to drive. Others focused on performance, but sacrificed efficiency. And many older hybrid systems still lacked the smart software and seamless driving experience people now expect from modern vehicles. Geely wanted to eliminate those trade-offs completely. So instead of treating the engine, electric motor, software, and chassis as separate systems, the company built everything around one connected AI-driven platform. At the center of this new setup is something Geely calls Full Domain AI 2.0, combined with its new ICMA architecture. The ICMA platform is an evolved version of Geely's CMA architecture, but redesigned specifically for advanced hybrid vehicles. And this is where the philosophy starts changing. Traditionally, cars operate with multiple independent control systems handling different tasks separately. One computer manages the engine, another controls stability systems, another handles the cabin, and so on. Geely decided to centralize everything into what is essentially a single intelligent brain. The driving systems, chassis controls, power management, and cockpit functions all communicate together in real time. Instead of reacting independently, the entire vehicle works as one coordinated system. But the real breakthrough may be something Geely calls AI cloud power. This system constantly collects outside environmental data, like temperature, humidity, traffic conditions, altitude, and driving load. Then artificial intelligence instantly adjusts the hybrid system to find the most efficient balance between petrol and electric power at every moment. In simple terms, the car is continuously teaching itself how to become more efficient while you drive. According to Geely, this AI-controlled energy management improves efficiency by more than 10% compared to conventional hybrid systems. That is a major leap, because older hybrids mainly relied on fixed programming and predefined operating logic. Geely's system behaves more dynamically, almost like the vehicle is actively adapting to the environment around it in real time. And underneath all of that software sits the engine that shocked the automotive world. The IHEV's dedicated hybrid engine reportedly achieves a record-breaking 48.41% thermal efficiency figure, making it one of the most efficient mass-produced combustion engines ever created. But Geely's engineers realized something else too. Even highly efficient engines still create compromises if they remain mechanically tied to the wheels all the time. So Geely strategically separated the engine and electric motor roles far more aggressively than traditional hybrids usually do. Instead of using an engine-centered design, the IHEV moves toward what Geely describes as a motor-led layout. That changes how the car feels completely. The electric motor now handles most of the driving experience, while the engine quietly focuses on generating energy in the background whenever needed. The result is a vehicle that behaves much more like an electric car, without requiring drivers to stop and recharge it. Acceleration becomes smoother, the cabin stays quieter, and low-speed driving feels more effortless and refined. The numbers behind the system are surprisingly aggressive too. The electric motor alone produces up to 230 kilowatts of power. Geely also claims the vehicle can operate on electric power nearly 80% of the time during typical driving conditions. In EV mode, the car can reach speeds up to 66 kilometers per hour, while acceleration from 0 to 30 kilometers per hour takes only 1.84 seconds. Those are serious performance figures for a hybrid vehicle focused primarily on efficiency. But Geely also understood that advanced technology means very little if drivers do not trust the system to remain safe and reliable long-term. That is why the company heavily emphasized safety engineering throughout the platform. The ICMA architecture was designed with complete oil-electric separation protection built directly into the vehicle structure. Meanwhile, Geely's battery safety system provides continuous 24-hour monitoring both inside the vehicle and through cloud-based systems. The battery itself uses liquid cooling and carries an IP68 dust and water resistance rating, one of the highest levels available for automotive battery protection. According to Geely, the system can also predict and identify more than 50 different fault types in real time before they become serious problems. Combined with Geely's large-scale validation and crash testing facilities, the company believes the IHEV platform could become one of the safest hybrid systems currently on the market. And that is what makes this technology so important. Geely is no longer simply building a better hybrid engine. It is trying to redesign the entire relationship between software, AI, electricity, combustion, safety, and driving itself. Before Geely shattered records, one impossible barrier stood above every engineer. Stay tuned to find out. The barrier everyone thought was impossible. Think of a combustion engine like a campfire trapped inside a sealed metal box. You throw fuel in, it ignites. The explosion forces a piston downward, and that movement eventually spins your wheels. On paper, the idea sounds surprisingly simple. But there is one massive problem. Fire creates heat, and heat does not care where you want it to go. It spreads everywhere. Into the engine walls, through the exhaust system, into the surrounding air. The engine is constantly trying to force that energy in one useful direction. But most of it escapes before it can do any real work. That has always been the fundamental weakness of combustion engines. There is also a physics rule standing in the way called the Carnot limit. The name sounds complicated, but the basic idea is actually simple. Every heat engine has a hard efficiency ceiling that cannot be ignored. The amount of usable energy you can extract depends on the temperature difference between the explosion inside the cylinder and the heat leaving through the exhaust. The larger that gap becomes, the more efficient the engine can theoretically be. But there is a catch. If the combustion temperature gets too high, the engine starts destroying itself from the inside. Pistons crack, metal weakens, and engine knock becomes catastrophic. On the other side, if the exhaust becomes too cool, modern emissions systems stop functioning properly. Engineers have been trapped between those two limits for decades. That is why companies like Toyota, Honda, BMW, and Volkswagen treated 40% thermal efficiency like a nearly impossible wall. Even reaching 41% took years of development, billions of dollars in research, and some incredibly clever engineering tricks. Toyota managed it using something called the Atkinson cycle. Instead of closing the intake valve normally, the engine keeps it open slightly longer during compression. That small adjustment reduces wasted energy and improves fuel efficiency without dramatically increasing engine stress. It sounds minor, but it was enough to push Toyota's famous 2.5-liter dynamic force engine to around 41% thermal efficiency. When that happened, the global auto industry reacted like a major scientific breakthrough had just occurred. Engineers published papers suggesting that going significantly beyond that point would be incredibly difficult, financially impractical, or simply unrealistic for mass production vehicles. And honestly, many companies stopped trying. At the time, the industry was becoming obsessed with fully electric vehicles anyway. Automakers across Europe, America, and Japan believed the future belonged entirely to batteries. Why continue investing huge amounts of money into combustion engines if governments were already planning to phase them out? That assumption would later become one of the most expensive mistakes the automotive industry ever made. Because while major Western automakers were pouring billions into EV-only futures, engineers in China were approaching the problem differently. They were not asking how to slowly improve the traditional engine. They were asking something much more dangerous. What happens if we redesign the entire system from the ground up? That single question created the first real crack in the efficiency wall. And the company leading that charge was one most people outside China never expected. Then one Chinese company suddenly pushed beyond limits nobody thought possible. Keep watching to find out more. The 46% shockwave that changed everything. Before Geely shocked the industry with 48.41% thermal efficiency, there was another number that quietly changed the entire game forever, 46%. Because that was the moment the global auto industry realized China was no longer catching up. It was starting to lead. The company that fired the first warning shot was BYD, short for Build Your Dreams. And instead of slightly improving the traditional hybrid formula, BYD looked at the entire system and decided most of it no longer made sense. In a normal hybrid vehicle, the petrol engine and the electric motor both help drive the wheels together. That sounds efficient, but it creates a major problem behind the scenes. The engine is constantly changing speed depending on traffic, hills, acceleration, braking, and gear shifts. 1 second it is revving high, the next second it is slowing down again. Every time the RPM changes, the engine drifts away from the narrow range where it operates most efficiently. That constant fluctuation wastes energy. BYD asked a completely different question. What if the engine stopped trying to drive the wheels most of the time? What if its only job was generating electricity? Instead of forcing the engine to constantly react to the road, BYD designed a system where electric motors handled most of the driving. The petrol engine could then remain locked at one carefully optimized RPM range where fuel efficiency peaked. No constant rev changes. No endless hunting through gears. No compromises between performance and efficiency. The engine only had to do one thing, and it could do it perfectly. That idea became BYD's DMI hybrid system, and the results shocked almost everyone in the automotive world. On their fifth-generation platform, BYD achieved an incredible 46.06% thermal efficiency figure. To most people, jumping from 41% to 46% may not sound revolutionary, but inside the industry, it was massive. Toyota spent roughly 2 decades and billions of dollars pushing efficiency from around 36% to 41%. That progress was considered one of the greatest engineering achievements in modern combustion engine history. BYD gained another 5 percentage points in a fraction of the time by completely rethinking how the engine should operate in the first place. The international automotive press immediately took notice. Some engineers were impressed, others were deeply uncomfortable, because suddenly, companies that had dominated engine technology for generations were being outpaced by a Chinese automaker using a fundamentally different philosophy. Behind closed doors, many legacy automakers had a quiet moment of panic, but publicly, most of them downplayed it. Executives convinced themselves this was only a regional success story. They argued Western buyers would never fully accept Chinese hybrid systems or Chinese automotive technology at scale. Ironically, that sounded almost identical to what American automakers once said about Japanese cars back in the 1980s. History has a habit of repeating itself, but while the rest of the industry was still trying to process BYD's 46% breakthrough, another Chinese company had already moved even further ahead. Geely had reportedly spent the previous 2 years working on something far more extreme, something designed not just to beat Toyota or BYD, but to completely redraw the limits of combustion engine efficiency itself. And that was how Geely introduced the 48.41% engine. But Geely was not chasing EVs, so which market did they target? Let's find out. The hybrid market Japan once controlled. What makes Geely's breakthrough even more surprising is that the company did not focus on the part of the market everyone expected. Most Chinese automakers spent the last several years aggressively chasing plug-in hybrids and fully electric vehicles because those categories received massive government support inside China. But Geely decided to target something very different, the traditional hybrid market, and that changes the entire story. In China, regular hybrid electric vehicles, or HEVs, are not officially classified as new energy vehicles. That may sound like a small technical detail, but it has huge consequences. Because HEVs do not qualify for the same level of subsidies, incentives, and policy advantages given to plug-in hybrids and fully electric cars. As a result, most domestic companies largely ignored the segment. That left the door wide open for Japanese automakers. For years, companies like Toyota and Honda dominated the traditional hybrid market, almost uncontested. Their hybrid systems built reputations for reliability, fuel economy, and smooth daily driving. In many ways, hybrid technology became Japan's territory. But Geely saw an opportunity hiding inside that neglected market. Instead of following the crowd into full EV competition, the company started building a next-generation intelligent hybrid system aimed directly at traditional EVs. And according to Geely, the results pushed hybrid technology further than anyone expected. At the center of the system is something called the Xingrui AI Cloud Power 2.0 large model. For decades, Toyota and Honda built their dominance around hybrid engineering expertise. But Geely is now challenging them not only on efficiency, but also on electric motor performance, software intelligence, digital architecture, and smart vehicle integration. That creates a very different kind of competitive threat, because Geely is not simply trying to copy traditional hybrid systems. It is trying to replace the entire idea of what a hybrid vehicle can be. And as the company prepares to expand its new high-efficiency HEV lineup in 2026, many analysts believe the pressure on Japanese automakers is only beginning. This breakthrough was leading somewhere even bigger than anybody expected. The future no one expected. Here is the reality most automakers do not openly admit. Pure electric vehicles are genuinely impressive in the right situations. They are quiet, smooth, incredibly efficient, and produce zero tailpipe emissions while driving. For city commuting and short daily trips, they can feel almost perfect. But they also come with trade-offs that millions of people around the world still are not fully ready to accept. A large electric SUV can require a battery pack weighing more than 500 kilograms. Charging infrastructure remains inconsistent across huge parts of the world, especially outside major cities. And for many drivers, range anxiety is not just a marketing phrase. It is a real concern tied to work, travel, family schedules, and daily convenience. That is where Geely's hybrid system changes the conversation completely. Because instead of forcing drivers to choose between combustion and electric power, the system tries to combine the strongest advantages of both technologies into one package. For everyday commuting, the vehicle behaves much like a fully electric car. You get the smooth acceleration, instant torque, quiet cabin, and refined low-speed driving experience people love about EVs. But unlike a pure electric vehicle, you are not tied to charging stations. The total driving range stretches beyond 2,000 kilometers, and refueling can happen at virtually any petrol station in the world. In many markets, the running costs per kilometer are also surprisingly close to what drivers would pay using a full EV. And perhaps the most shocking part is the type of vehicle delivering those numbers. This is not some tiny, lightweight commuter car built purely for efficiency testing. It is a full-size SUV capable of consuming less than 2.5 liters of fuel per 100 kilometers under real-world driving conditions. That is exactly why so many automakers are suddenly paying attention. Because for more than a century, the internal combustion engine was considered European territory. Countries like Germany, France, and the United Kingdom helped invent and dominate the technology for generations. Then Japan spent decades refining combustion efficiency to levels many engineers believed were already approaching the physical limit. Now, the world's efficiency record belongs to a Chinese company that barely had a serious international automotive presence 15 years ago. That is not a small industry shift. That is a massive power change happening in real time. And catching up will not be easy. You cannot close this kind of engineering gap with a software update, a redesigned logo, or a clever marketing campaign. It requires rebuilding research pipelines, retraining engineering teams, questioning old assumptions, and investing years into entirely new development strategies. That becomes even harder when many Western automakers are simultaneously being pushed toward fully electric futures by governments, investors, and regulations, while also realizing their combustion technology may now be falling behind. But for consumers, this growing competition could actually become a very good thing. Historically, whenever a major engineering breakthrough enters the market, the entire industry is forced to improve. Prices become more competitive, innovation accelerates, and technology spreads faster than expected. Eventually, legacy automakers will respond. They almost have no choice. The real question is how much the global automotive landscape changes before they do. Because what Geely has proven goes far beyond a single efficiency number. The combustion engine was never truly out of ideas. The real limit was how many companies still believed it was worth pushing further. And now that someone finally did, the entire industry may have to rethink what the future of cars actually looks like. If you made it this far, you probably understand more about engine efficiency than most people casually talking about cars online. And honestly, that feels like the perfect place to end. What do you think about China's insane 48.41% breakthrough engine? Let us know in the comments section below. In the end, this was never just about one engine. It was about a global industry shift nobody expected. China proved the combustion engine still had room to evolve. And now the rest of the car world is being forced to respond. If you enjoyed this video, like, subscribe, and And stay tuned for more stories reshaping the future of technology.